Hi class, and welcome to another lesson. This is the square root function. It's lesson 2.9. When we look at this, the reason why we talk about the square root function is because so often in mathematics we talk about the inverse, such as like the inverse of adding is subtracting. It's the opposite. The inverse of multiplying is dividing. Well, we talk about squared numbers a lot, and the inverse of squaring a number is square rooting that number. So such as when we have y squared equals x, if I want to get y all by itself, well, I have to do the inverse operation, or I have to square root both sides. So now we have y equals the square root of x. And for a later lesson, we talk about how it is the positive and negative square root of x. For this lesson, though, we're not going to worry about that because I'm always going to give you either positive or negative. So this one is just going to be y equals the square root of x. So from this point, class, I want you to put this into your calculator and see what you get. Y equals the square root of x. So please do that with me. Open up your calculator. Y equals the square root is you're going to press second and the squared button. So right there, you should have the square root symbol show up. Y equals the square root of x. We graph that. And notice how it's a curve. It's a curve starting at 0, 0. If you were to look at the table here, you would see several points here. You get errors for all these negative numbers, and the reason for that is you cannot take the square root of a negative number and get a real solution. So we start at 0, 0, because the square root of 0 is 0. And then we have 1, because the square root of 1 is 1. The next number that's convenient for us to plot is 4, because the square root of 4 is 2. That's where we get the y value of 2. So we can get 9, the square root of 9 is 3. If you were to scroll all the way up to 16, you'd get a y value of 4, and so on and so forth. So if we were to sketch this graph right now, which is what I'm going to want you to do on your next chapter test, you would plot those convenient points at 0, 0, at 1, 1, and at 4, 2, because the square root of 4 is 2. And then if we were to find 9 on here, so 5, 6, 7, 8, 9, then we would get 3, and we would get this curve. Just like that. Okay, so that's what I want you to sketch on your graph. So now we're going back to domain and range again. Let's talk about the domain first. That's the x values. Whoa, let's get this line instead. Here we go. There we are. So we're going to start at 0, right? So you have no x values over here. You start at an x value of 0, and how far to the right do you go? You don't ever stop, do you? Your x values can go all the way up to infinity. So if it starts at 0, can x equal 0? The answer is yes. On this graph, the absolute, or the square root of 0 is 0. So x can equal 0. It includes it. So it goes from 0, we're going to have a bracket, all the way up to positive infinity. Positive infinity always has a parenthesis. So now let's talk about the y's, or the range. So as we go from bottom to top, where do our y values start? They start right there, which has a y value of, once again, 0. And again, it does include 0, so we're going to have a bracket there. And how high does this line go? When it's 0, it's 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. When x is 16, y is 4. When x is 25, y is 5. As x continues to get bigger and bigger and bigger, y gets bigger and bigger and bigger until it reaches all the way up to infinity. There is no ceiling on this one. It'll go forever and always all the way up to positive infinity. So that's what we get for the domain and the range on this one. When that's the case, let's talk about our set notation. That's where we say x such that x and y such that y. We say x is everything to the right of 0. So if it's everything to the right, we say that it's greater than. Because it includes 0, it's greater than or equal to 0. So x such that x is greater than or equal to 0. In the same way, it's everything above 0 when we talk about the range. The range goes up and down. So if it's everything above 0, it's everything greater than and greater than or equal to 0. To give you guys an easy hint on this one. Whenever we talk about the square root function, it's always going to be the included value of where it starts. So you're always going to have brackets right here, and you're always going to have an equal sign with your inequality right here. So it's going to be greater than or equal to, and it'll always have brackets. It's going to be like that for this entire lesson. So that should help you out with this one. So that's what I expect from you on your next chapter test. So now let's practice this a few more times so we can get good at it. Problem number 2, it's the square root of x plus 3. Now the square root function is always going to be a curve. So if we want to put this into our calculator, we can. Let's do that. We have y equals the square root of x. Now we're going to say it is plus 3. Make sure your plus 3 is outside the square root symbol. Now we press graph, and look what happened. All it did is it shifted our graph up 3 units. It's very, very simple on why this happens. If you just take a look at this and just think about it, what happens when x is 0? Well, the square root of 0 is 0, and then 0 plus 3 is 3. So we get a y value of 3. What happens when x is a positive 1? What's the square root of 1? It's 1. And then 1 plus 3 is 4. So when x is 1, y is 4. Let's do this one more time. What happens when x is 4? Well, the square root of 4 is 2, and 2 plus 3 is 5. So we get this 0, 3, 1, 4, 4, 5. 0, 3, 1, 4, and 4, 5. You get this exact same curve. The only difference is that it is shifted up 3 units. If you wanted to go to your table and check this, 0, 3, 1, 4, 4, 5. Can we remember that? Second table. Here is 0, 3, 1, 4, and 4, 5. So you could always go to your table and look at those. Notice how there's still errors, everything to the left of 0, because there's no such thing as taking the square root of a negative number. There's no real solution, that is. So as we go back here, here's our graph. We sketched it. Now let's talk about the domain and the range. The domain, there's no values over here. You're starting at 0. This value right here is the point 0, 3. So as far as the x value is concerned, we start at 0, and then we go to 1, 2, 3, 4, 5, and all the way to positive infinity. We start at 0, and we go to positive infinity. Infinity always has parentheses. It's going to include 0, so we're going to have a bracket. Our y value is going to be different, and the reason for that is because our graph is shifted up 3 units. So instead of starting at 0, we don't start at 1, we don't start at 2. Bam, we start at the y value of 3. So there's no such thing as having any y values down here. They cannot exist. They start right here at 3. And then they go to positive infinity. So they start at 3, and how high does my graph go? As long as my x's will increase, my y's will increase as well. So we have positive infinity, and it's going to start at 3. It includes 3, so we're going to bracket that. So 3 to positive infinity. So now for our domain, we say x such that x and y such that y for our set notation. It's everything to the right of 0, which means it's greater than or equal to 0. It's everything above 3, so it's y such that y is greater than or equal to 3. Why don't you guys now pause the video, hopefully 1 and 2 make sense, try numbers 3 and number 4 on your own. Okay, pause the video, try those two. When you got number 3, if you put this into your calculator, or if you did it just by looking at, what happens when you have an x and y table, you should have got the ordered pairs of a -3, 0, a -2, positive 1, a positive 1, positive 2, and 6, 3. All 4 of these points would fit on our graph. So a -3, 0, a -2, positive 1, positive 1, positive 2, and a positive 6, positive 3. So we still get that curve. Notice what happened to our first original graph. It just shifted left 3 units. So when this 3 was outside the square root sign, it shifted it up 3. When it's inside the square root sign, it shifted it left 3. So notice how it's kind of the opposite of this again. When you think left and right, usually you think of positive as shifting right and negative as shifting left. Well, in this case, it's opposite again. So when it's x plus 3, it shifts it to the left 3. Alright, let's see how you did on the domain and the range. The domain starts right here at a negative 3. It includes negative 3. How far to the right does it go? Positive infinity. So it starts at a negative 3 and it goes all the way to positive infinity. For our y values, it starts right there at 0. This point is a negative 3, 0. So as far as our y is concerned, it starts at 0. How high does this red line go? It doesn't go up very fast. It really flattens out here pretty quick, but it does continue to go up forever and ever and ever, and it will not stop going up as long as our x's increase. So our range goes from 0 and it goes all the way up to positive infinity. So x such that x is everything that is greater than or equal to a negative 3, y such that y is greater than or equal to 0. And last one here, problem number 4. This one, right away, you could see, if you remember our rules for how graphs shift, this shifts left and right, and it's opposite, so it's going to be left 3. This one shifts it up and down, so it's going to be down 5. So left 3, down 1, 2, 3, 4, 5, and we get that point right there. The other ones, besides negative 3, negative 5, are negative 2, negative 4. You can get this from the graph or just by plugging in values. Right 1, down 3, and right 6, down 2. So you would get this graph when you put it into your calculator. That's what I expect on the test, and now let's talk about the domain and range. Starting at a domain, this point right here is at negative 3, negative 5. So the x value there is the negative 3. So it starts at negative 3 and poof, it goes all the way to the right to positive infinity. It includes negative 3, so we're going to have a bracket all the way up to positive infinity. Our y values, we don't have any negative y values until right there at negative 5. That's the very first one. So nothing below negative 5. Negative 5 is the lowest negative range value. And then how high does that line go? Even though it kind of flattens out pretty quickly, it goes all the way to positive infinity. As your x's increase, your y's get bigger and bigger and bigger. So there's your interval notation. For your set notation, x such that x is greater than or equal to a negative 3. Your range, y such that y is everything that is above negative 5. So if it's above, we say it's greater than or equal to a negative 5. Last thing I want you to be aware of, let's say you get this on an assignment. X equals the absolute value of y plus 3. You can't graph this on your graphing calculator. So if you can't graph it on your graphing calculator, let's just put in some points for x and y. Let's make a little table. Let's find out, being that we're going to see what happens for x, let's put in values for y. So let's put in 0. That's easy enough. What's the square root of 0? Well, it's 0. And what's 0 plus 3? 3. So when y is 0, x becomes 0 plus 3, or 3. Let's do this again. What happens when we put in a value of 1 for y? Well, what's the square root of 1? It's 1. And what's 1 plus 3? 1 plus 3 is 4. So when we put in a 1 for y, we get a value of 4 for x. Let's try this again, shall we? Let's put in a value of, let's see, we did 0, we did 1, let's do 4. The reason why we would do that is because the square root of 4 is 2. So when we put in 4 for y, we get the square root of 4 is 2, and then 2 plus this 3, 2 plus 3 is 5. So when we put in a 4 for y, we get a 5 for x. Let's do this one more time. Let's put in the number 9. because the square root of 9 is 3. So when we put in a 9 for y, the square root of 9 is 3, and 3 plus 3 is 6. Whew! So now our graph, if we were to plot these points, we would get 3, 0. So something like that. We would get 4, 1. We would get 5, 4. And we would get 6, 9. Maybe something like that. And there is our graph. So if you had to sketch one that looks like that, you would just plot some convenient points. You wouldn't even use your graphing calculator. Hopefully this makes sense. As always, be sure to ask me any questions if you have any when you get to class tomorrow.